All right, that's me. I'm Kathy Treankler. I'm from the lovely city of Green Bay, Wisconsin. I'm sure you've all heard of it. Our Packers are from there. It's a little cooler there today than it is here. I'm here to talk to you about our transformation and that we went through just recently. And our transformation is probably a little bit different than other transformations you've heard about this week. For us, it was born out of something that we were doing for a customer. And then as we looked at the external side of IIoT, we looked at the internal side, or had to look at the internal side of it as well. So Trinks, like I said, we've been around for a while in Green Bay. Since 1935, we actually purchased the business from a family-owned company and have transitioned over the years. We build large and not so large compression molding presses. So we deal mostly with the manufacturing world. I did not see a lot of manufacturing people that are actually doing manufacturing on the list of attendees, but I can tell you that the manufacturing world is slower on the uptake of IT and OT converging. The main mentality of our customers is, if it's not broke, we're not going to fix it. So don't come knocking on our door for any of this convergence stuff, but I guarantee you when it does break, they're at our door asking us to fix whatever is down in their plant, and then technology becomes the forefront of what it is that we're discussing. As I said, we make presses, so we're dealing with automation and anything that surrounds that press. So whether it be the press itself, ancillary items that might either be prior to the press manufacturing process or after. The services that we offer, our niche in the market is controls engineering. So for us, you can find other manufacturers of presses that are out there. I could name our competitors, but why bother? We're known for the control side. So IT is very important to us, not so much to our customers. There aren't very many of our plants that we service that have networked their machines as of yet. They are pretty much separate or deal with each other separate. IT is one world and manufacturing is another. This quote has become more and more of a point that we use every day at Trinks, and it is that a key to a vital life is an eagerness to learn and a willingness to change. And all of us in this room, regardless of what industry you work in, and if you've been around the industry for 10 years or 40 years, you've gone through changes, and probably one of the most notable that we've all gone through is our cell phones. I remember back in the day where I had a rotary phone, and then it was pretty cool to go from rotary to push button, and now my entire life is on my phone. So the very things that I used to do physically, go to the grocery store and pick up groceries, I now can do on a phone. So it was something that's an example of an IIoT in your world that has happened as a convergence. Those two things have come together, and now you can do everything on that little device. So along with learning or needing to learn and needing to change, we all have to look at this convergence that everyone's talking about. And this is something that's available out when you do a little Google search on IIoT, that 90% of CEOs believe the digital economy will impact their industry. Okay, that's a pretty broad statement, and everybody believes it, or just about everybody does. However, only 15% of us are actually doing something to concentrate on it and put something into focus. I mean, looking at you guys out there, how many of you actually have an active plan in place? None, and one that's going like this. So that just tells you that's why you're here, right? That's what we're here to talk about. We can talk about it all we want, but if you're not actively doing something, then you're not addressing the situation. So I think that ARC's got the right idea. We're trying to inform everyone what it's going to take to make that convergence. So for us internally, I came into the company and said, all right, guys, this is what we're going to do now. We are going to look at increasing our sales. So in order to increase sales, I have to sell more presses. In order to sell more presses, I need my controls engineering guys to program to program more, to program faster. On average, it was taking them about 15 weeks to do a program for a 20 to 26 week lead time on a press. So they were still within the lead time of the press. However, they were only getting about 3 presses per year done, and I had 3 controls engineers. So if you do the math, if I want to expand, I have to add another engineer. Well, I didn't want to add another engineer. That's another $100,000 to my operating budget. And so I'm looking to conserve how I can do that. So time was of the essence. And then their knowledge base was a little bit different. I have a gentleman that's been with me for 40 years, has been programming in the controls realm since relay logic was out. You may or may not know what that is. And times were changing. Technology was changing. The new guys that came in had their own way of thinking and thought that they knew everything about programming. So we had a little bit of an imbalance between the old and the new. I wanted them to be able to meet some of the standards that we had within our shop. On the shop floor, we were creating standards for components. I wanted engineering to do the same, create some sort of a standard process in programming. And so we took a look at that as there's got to be a way that although each press is different that we design, they still have some of the general same hydraulic components. There's got to be a way to do some sort of programming that's similar across all of them. So we worked with our partners at Rockwell to introduce modular programming. So now we had a modular piece that could be used on every press. We could tweak it if we needed to based on the environment it was going into, but for the most part, that modular programming helped to cut from what was a 15-week process for them down to 3 weeks. That's a huge change in what each of those engineers could do. So now when I have an engineer retiring, am I hiring a new engineer to replace him? I don't need to, because I've just tripled my capacity on each of the engineers that I currently have within my facility. So that was an example of our sales drove that change, that IIoT convergence. And it wasn't just about the engineers that needed to take a look at this. We got the entire shop floor. There were no more barriers. We weren't going to have barriers between engineering and the shop floor or our service technicians and the shop floor. All of us worked together to come up with what that modular program was. Nothing? Really? I thought this would be the most creative slide that you guys saw. So, this is Larry. This is my guy that's going to be retiring. And all of you, if you've worked in the business, has one of these. They're called your historian, right? They're the guy that knows, or gal, that knows everything. They've been around forever. They're the person that you go to for any advice. They're the person that you go to help transition someone new in the business into what it is that you do. So Larry learned through books. He learned through real life application, trial and error, whatever the case might be. In our case, Larry is leaving in April. And as we started this digital transformation that I'll talk about in actual application that we had later on, we realized that when Larry goes, we don't have someone to go back to and say, hey, what would you do in this instance? Or what have you experienced in the past? So we realized that we need to start capturing through some sort of IT, OT, really, experience what is in Larry's head. Now, you may know this guy too. He's new. This is Baby Yoda. Our Baby Yoda's name is Casey. Casey's a really intelligent kid, knows a lot of stuff. But everything he's learned from Google. He's learned from the internet. He's always had the internet in his life. How do you get someone who really doesn't like computers, other than the programming side of the world, to communicate with this kid that only knows virtual reality, the internet, and all of its applications? Well, we decided we're going to do some augmented reality and actually take scenarios that Larry has run into and record them and create a library for our new technicians that come in to help bridge that gap between the older generation leaving and the newer generation coming in. So let's talk a little bit about our actual transformation that we had. We had a press that was 30 years old. And if you are exposed to anything in manufacturing, you know that most of the manufacturing in the US runs on presses, on equipment that can be from the 40s, 50s, 60s. Steel lasts a long time. So the frame of the press was just fine. There was nothing wrong with it. The controls were about 20 years old, so we decided to gut the controls and put in the latest and greatest. And that's when we started realizing some of our internal processes needed to change, which I already talked about. And we said, all right, if we're going to do this for a customer, what customer are we going to go into and update to this fashion? And there's really a good way to do this and there's a bad way to do it. It doesn't make sense for someone to come in and have your digital transformation be that you'd update all of your equipment overnight. It's a capital expenditure that goes way beyond what it should, and it should be more of a transition. So the customer that we're working with, we're actually looking at bringing in one new press, pulling an old press off the floor, retrofitting the old press, and then doing kind of a circulation until they're all updated and able to be networked. The press that we worked on, like I said, that frame was older. Now we have a press that can update our customer in real time within a millisecond. They're now getting data based off of KPIs that they wanted, and we're concentrating on the actual mold that is producing the equipment that they're giving to their end user. The mold itself, as you may or may not know, a mold can cost anywhere from $30,000 to $1 million, depending on the intricacy of the mold itself. Our press is just the vehicle that gets the material in there and then compresses it, releases it, and then it moves on in the process. The press, the environment that the press was in, it's a rotary table, and on this rotary table, there can be up to 4 actual molds working within the cycle. The cycle is about a minute or a little less than a minute, and the way that the customer runs the shop floor is they would have a quality control person come out once an hour and would check basically if the parts were good. They had measurements that they were taking, and then they'd go back to their workstation and let the press run. Well, if they came back out an hour later and they found any sort of issue, they would scrap everything or put it off to the side. They wouldn't actually scrap it. They'd put it off to the side, and then someone would have to go through every single part and hopefully not find too many. So we said, okay, we want to be able to give them in real time, and this was already talked about. A shop floor real time is different than IT real time. In real time, we want to be able to give them information that they have a part that was just made, that came out of their mold, that will not pass inspection. So we were given the KPIs that had to be met, and now we have a press that is recording everything about that mold at that period of time. So the velocity, pressure, tonnage, everything is all recorded, and you can actually print a certificate for that particular part. If by chance a part does not pass, the press can be programmed to shut down, which you usually don't want to do when you're dealing with plastic because you run into other issues with the machine. Or in our case, it sends a signal to the quality person to come out and take a look at the machine because something's not going right. We have found in manufacturing that the biggest issue that our operators cause for their facilities is they tweak something on the machine. So there's a difference between third shift and first shift as to what the runs were, and no one can figure out because nobody touched the machine and did anything different, but somehow these parts were made better on one shift over another. Now we have actually quality data to give to the company to show what it is that's varying from shift to shift. We've done this type of reporting in the past, but we were always told that although the reports were great and they gave great information, we weren't giving the right information and we weren't giving it in a timely manner. So now we have a way hooked in through the controls of the press to communicate back to the quality inspector that's on the actual shop floor. When we talk about remote, any type of remote integration on a shop floor, we need to make sure that what it is that we're delivering to our customers from a press manufacturing standpoint is what they actually need. We have made assumptions in the past where we've gone in and say, you need this, you need that, you need this, and you need that. And they come back to us and say, that's all great technology, but it doesn't really fit our need. What I have found has helped us the most in our transformation is truly listening to our customer base. And as we listen to our customer base and truly are engaged listening, not coming in with assumptions, but truly engaged in what it is that we need, they need, we've learned what we need as well internally. So I have found that very ironic that our customers have taught us to be better at what we do. And it's supposed to be the other way around. The idea of the smart machine and the smart technology that we now have in these presses that we're going to start building goes to show that it's not that you have to work harder to have IT and OT converge. You just have to work smarter. You have to listen to both sides, and you have to have them work together. And that's really what our transformation has been about. It's been about creating this press that now incorporates not only this real-time interaction, but we're also experimenting with augmented reality. And augmented reality not just to train our older workforce with our newer, but also to help our service department service those machines from in our facility. And I have, if anybody's interested to show our application of augmented reality, I do have a clip of our machine and pulling out an assembly and showing how that assembly is put together, maintained, different part numbers on it, so on and so forth. So if you're interested after, you can come and see me about that. Thank you for your time.